This is question number 20 on the Unit 1 test review. The skills that it's actually pushing you to remember and know how to execute are: how do I understand the story behind the graph, and how do I use the graph to actually answer a series of questions? So here's our story. At a local racetrack, a motorcycle and a race car begin a race to see who can get to the finish line first. The graph below models the distance each driver travels from the start of the race. And if you look at the graph, you can see distance is measured in meters. Distance each driver travels from the start of the race. Based on the graph, answer the following questions. So class, a lot of times for me, before I even start to answer the questions, I just make sense of the graph. You can see that they're measuring time on the x-axis in seconds. And we already talked about distance that the vehicle traveled in meters from the starting line. And if you look at this, the motorcycle is the solid line and the race car is the dashed line. So all of these points on these two graphs tell us how far away from the finish line is this particular vehicle at various values of time in the race. So here comes the first question. Which racer is traveling the fastest at 6 seconds? The fastest at 6 seconds. So we're going to go right down here where it's 6 seconds, and you can see, class, I'm going to draw a line. Oops, that's not a very good line. I'm going to draw a line right there. And then I drew it at 5 seconds. That's not going to work. Let's try putting a little dash here. There's 6 seconds and 6 seconds. So class, when we're talking about speed of travel, we're talking about the slope of the line, which is going to give us meters per second. And if you look at this, the dash line, the race car, is relatively flat. And the motorcycle definitely has a steeper slope than the race car. So we're going to say which one's traveling fastest at 6 seconds? It's going to be the motorcycle. All right. Now, similar question. Which racer is traveling the fastest at 14 seconds? So here's our 14-second marker. Take a look. We got where we're crossing the dash line, which is the race car, and the solid line, which is the motorcycle. You can see now, class, the race car actually has a steeper slope, which means it is traveling faster than the slope of the motorcycle. So the race car is definitely traveling faster. Remember, traveling faster means highest slope or biggest slope. Next question. Which racer is in the lead at 17 seconds? I'll change my colors now. How about in the lead at 17 seconds, which is right here? Let's take a look. There is the crossover from 17 seconds for the motorcycle. And here is the race car. Now, class, if you look at those two marks, the race car has gone like 225, maybe 220 meters, whereas the motorcycle has only gone like maybe 170 meters. So in this case, we can see the race car definitely has traveled farther and in the lead at 17 seconds. Which racer is in the lead at 10 seconds? So now we go to our marker at 10 seconds. Now take a look, class. This is how far the race car traveled. That's maybe about 20 to 30 meters. And take a look at the motorcycle. The motorcycle at 10 seconds has traveled above 50 meters, maybe about 75 meters. So clearly the motorcycle is in the lead at 10 seconds. So all these things, class, are hopefully helping you to really understand how does this graph actually tell the story of the entire race, or at least the race up to about 20 seconds. All right, let's change colors to orange. I will try red. At what time have both racers traveled the same distance? Well, that's not hard to see, class. Think about the story. They start off together at the starting line. As they begin, the solid line or the motorcycle jumps out into the lead. The race car is going slower. And as the race car goes further and further along, you can see it's catching up, catching up, catching up. And right here at this point, right here, the motorcycle and the race car are both at the exact same place. They're both about 160, somewhere around 160 meters. The big thing here is it's asking us at what time, and that's going to be at 15 seconds. So approximately 15 seconds. Letter F, which racer is first to travel 50 meters? Let's change that to a different color. Which one is first to travel 50 meters? Well, I'm going to go ahead and make a mark at 50 meters right here. And you can see at 50 meters, it actually took the solid line, which is the motorcycle, about 8.5 seconds to get to 50 meters. It took the race car, if you look at 50 meters right here, it took them maybe like 12.5 seconds. So clearly the motorcycle is traveling, it's getting there first. It's first to reach 50 meters, somewhere around 8.5 seconds. So that is letter F, and that is the motorcycle. Next one. If the finish line is 1,000 meters from the start, so thinking about this, class, we've only gone 50 meters on our graph. We're going to go really, really farther, like twice as far up on our graph, way at the top. Which driver will win the race? Well, if you look at this, at about 17 or 18 seconds, look at how fast the race car is going compared to the motorcycle. It is the steepness of that line is so steep compared to the actual motorcycle. So we can say, class, this graph will continue, and as it continues, it's going to keep on going faster and faster. The rate of change in speed for the race car is huge compared to the rate of change for the motorcycle. So we look at this and say, based on the graph, we're going to predict that the race car is going to win the race. And that's based on what is our final slope that we see before the graph actually stops tracking their progress. And it's the race car. And then, which vehicle appears to have an exponential graph? So class, if we think about this, we've learned this in this unit. An exponential graph can start off very flat, but when it starts to grow, it grows exponentially. That means every time we add a little bit to the graph, it's multiplying the speed and getting very, very fast. So if you look at this graph, I would tell you it is pretty safe to predict that this right here, this graph right here, the race car, appears to be exponential. And I don't really know what this graph is, class. It could also be exponential, but just growing at a slower speed. But it looks very much like a quadratic. Probably a quadratic. So when we think about this, which appears to have an exponential graph, it's the one that's growing at a very, very fast speed the farther we go along on our x-axis. So I'm going to say, which one is this? Which one do you think it is? We think it is the race car. And I'm going to give you a chance, class, to write this down. If all you write is race car, then you're not really listening to the video. For this one, it says, why do you think this is? Why? You should actually answer based on the graph. You can talk about how you believe it's exponential because the speed is changing at a much faster rate than for the motorcycle. It could just be the shape of the graph itself, starts off relatively flat, but then starts to shoot up very quickly. All of these things will be a visible evidence to support that your race car is actually following an exponential pattern. And that is the end of question number 20.